So we're going to apply this normal distribution and standard normal distribution. And we're going to look at how these applications look in the bell curve and how to solve them in the calculator. So let's just jump in and look at some of these. So again, just like when we had our rectangular uniform distribution, when we looked at the area under the curve, even though it was a flat curve, that was our probability that an event would happen within that interval, whatever interval we were looking at. Whether it was the whole thing, then the probability was 1, it was going to happen. If it was half of it, the probability was 0.5 that it would happen within that interval. So that idea carries over to this. This time we just have a curve, but the shaded area represents the probability that the x that I'm talking about is going to be in this part of the curve. That's all of that this right here is saying, is that x is less than x, okay? The x that I'm talking about, what is the probability that it's going to be in this area? Less than whatever x I am talking about, okay? That's what that notation means. The area to the right is then x is greater than my practice point, my critical value, it's called in some books, okay? X is going to be greater than that critical value. And we can find that if we know this value here and subtract it from 1, we're going to end up with this value here. Because the whole thing, the probability has to be 1. So this idea of complement is still there and still with us. So if we find out one part, the shaded part, we know how much isn't shaded, and we can switch those inequality symbols and have those areas being the same. So we got left to the vertical line, we're going to be less than, greater than is going to be 1 minus that less than. We can also figure that out. And this is, again, continuous distributions, measurement, time, things like that. Okay. Otherwise, we'd be using the binomial distribution theorem and those discrete distribution theorems. So here we have an example, final exam on a score of statistics class, normally distributed. And my face is right on the calculator, of course. Maybe if I go right there. A mean of 63, a standard deviation of 5. Hopefully that makes some sense to you now. We know what those things mean. Find the probability that a randomly selected student scored more than 65 on the exam. Well, I'm just going to draw a curve before we get into the, I don't know if that's over my face or not because I can't see my face once I get a pen. Okay, here's my curve. And this mean is 63. That's right here, right? So 65 is in this area. It's larger than the mean. So I'm asking for the probability that a randomly selected student scored more than 65. So that's going to be this area from here all the way out. So it's going to be a lot less than half, right? And if we take the standard deviation of 5, okay, this is going to be within that first standard deviation. So we can kind of figure it out a little bit that way with our percentages. So that's what I'm figuring out. What is the area under a curve from 65 outward? So on your calculator, you're going to go to the second distribution, and then you're going to be looking for normal CDF. You're going to put in the z that we're interested in, our critical value goes first. Our critical value, use a comma. And since we're interested in the critical value up to, well, pretty much a very large number, right, infinity, that is where this, right down here, it shows us our critical value. And then we actually put an exponential notation. You can put it in as 10 to the 99th power. What we're saying is just some large number out there. So they usually use this as a standard large number. You can go 1e99, meaning that you're going to go to the 99th power. Then you're going to put in the mean and then the standard deviation. That's how you enter it into the calculator. The placement of our large number is going to be here, this upper value. Since the upper value is pretty much infinity, I'm having a very large number here. When we do it on the other end of the curve, it will be a negative very large number, and I'm going to lead with that, but we'll show one of those examples. Then I'm going to press the key, and all sorts of excitement happens. I get an answer, right? On a historical note, we used to use z-scores, and charts in the books would have these z-charts in the back of the book, and you would actually calculate the z and then go find what area it represented on the chart. And we would have to figure out whether we were adding that to 0.5, subtracting it from 0.5, and it would be a little bit tedious. It worked. We did that for years. But right now on the calculator, you can find out that the area to the right of 65 is going to be about 34% of our students are going to score 65 and higher. A table, just to see what a table looks like. Right here, you would find your value. And since we were talking about all the distance leading up to it, we would have to add 0.5, we'd have to add half of it. And then that number is what we would take away from 1 to get that remaining value. So it was a little cumbersome and tedious, but z-charts are still valuable to a lot of people that solve things that way. Excuse me. If we're going to find the percentile for a student scoring 65 out of 100 with a mean of 63 and a standard deviation of 5, here we're talking about scoring 65 out of 100 with a mean and a standard deviation. I'm not talking about the last one we had. Okay, I'll draw my little picture. The last one we talked about had the same numbers, right? But when I 65, I was talking about this area over here. This time, I'm talking about going all the way up to that number. So I'm starting off with my negative 10 to the 99th power. Then my critical value, the number I'm interested in, my mean, and my standard deviation. It's the same probability that a score is less than 65 when it's worded like this. The probability that the selected student scored less than 65 is this. So 65 is about at the 66th percentile, which we figured from our other score as well. Probability that the selected student scored less than 85 with a mean of 63. Now the 85 is very high if the mean is 63. So this is going to be a really small number. But again, if they're scoring less than, I do think it's helpful to draw a picture. Just so you know, here's our mean, here's our number, and I'm interested in less than that number. So I'm going to have that negative number for my lower value. So I have that negative coming in there, right here, when I enter it in. And I get, sure, almost everybody is going to score less than 85 on this test if it had the mean of 63. Now I want to go backwards and think about, if I have a percentile in mind, I want to find a score that is associated with that percentile. Compare the wording of this problem with the wording in the problem that we had before. Before we had a certain number. A student, I want to know what the percentage is that they scored less than. I'm trying to find out the percentage. Here I'm given the percentage. Find the 99th percentile. Which scores are going to be in that 99th percentile? So I'm kind of going backwards on this one. So I'm going to use a different function on the calculator, and it's going to be the inverse norm. Again, our calculator does marvelous things for us. Under the second distribution number again, our key, we're going to find our inverse norm, and we're going to input the area to the left, the mean, and the standard deviation. The area to the left, according to this problem, is 0.90. I want to find the 90th percentile with a mean of 63 and a standard deviation of 5. And when I put that into the calculator, I get that 69.4 is my 90th percentile. So anyone that gets higher than that is in that upper 10%. Anyone that gets lower than that is in that 90th percentile group. This test evidently was very hard if 69 is in the 90th percentile. So let's look at some more examples. Suppose that the average number of hours that household personal computers use for entertainment is 2 hours a day. Average, mean, mu, whatever you want to call it, it's going to be 2. Excuse me. Assume that the times of entertainment are normally distributed. Standard deviation for times are a half hour. So I'm at 2 hours in the middle, and I go a half hour on either side of it. That's going to get me that 68%. Just keep that picture in your mind. I might end up drawing a picture anyway. I usually do. Find the probability that a household personal computer is used for entertainment between 1.8 and 2.75 hours a day. Okay, so this time I am going to draw a picture. My mean is 2, and I'm talking about my critical value. I'm looking at 1.8 up to 2.75. I want to know this, and notice it straddles the mean in this case. I want some information on one side and some information on the other side. So how do we do that? Well, we're going to let our amount of time in hours look like this. Now, what is this telling me? This is just giving me the information of the standard deviation and the mu. And I want to find my x, the probability that x is between these two numbers, my lower limit and my upper limit. So the probability that we're looking for is right in between here. And how do I get this number? I am going to put in, for my probability, I start off with my lower limit. This time I'm not interested in the area all the way negative. I lost my picture. I am interested in that area in between. So my lower limit is going to be the 1.8. You can see part of it on the calculator here. But I'll put in the 1.8 first, put a comma, then you put in 2.75 and a comma. And my mu, excuse me, comma, and standard deviation, comma. In parenthesis, don't have to put that last comma. Hit enter, and you end up with your percentage. Excuse me, I'm going to take a drink. Historically, when we were using the z-charts, we would actually have to calculate the amount on one side of the mean, then the amount on the other side of the mean, and then add those two numbers together. But using the calculator, it does the whole thing, which is kind of nice. We're using the same problem here, but this time we're trying to find the probability. Well, actually, it's the same thing. It's just going to walk us through it a little bit further. It's showing us a picture. It's drawing us so much better than my drawing. Notice that we're straddling the mean, and so I have a lower limit and an upper limit, then my mean, then my standard deviation. Since I already did a picture, probably don't need to see that again. Okay. This time we're going to do that backwards one. I'm given the percentile. So find the 25th percentile. So what are my limits here of the 25th percentile? What is my critical value? Yeah, it's going to go down to nothing on one side since the other side gets larger. But what is that upper bound? So again, we're going to use that inverse norm to find out. And the inverse norm, and then I'm going to put in my percentile right here, my percentile, then my standard, then my mu, and then my standard deviation. So the only thing I'm missing, I don't have that other bound, right, when I'm trying to find the inverse norm. And the maximum number of hours each day, the bottom quartile of household spends is 1.6. That is my critical value. If they spend more than that, they are not in that bottom percentile, is what this is telling me. Here is another just practice. In the United States, ages 13 to 55 plus of smartphone users, approximate age follows a normal distribution. It's age, so it is a continuous distribution. Standard deviation and mean are listed right here, and also in our notation down here. So we want to find the 80th percentile. Remember, when we're given the percentile, we use this inverse norm. I'm going to put the inverse norm, the percentile we're after, the lower, the upper, and then the lower. And it comes out at 48.6 years. I'm just going to draw my little thing, just because, right? So what we're asking for when we're talking about the 80th percentile, that is up here, right? We're talking about all of this information here leading up to this. And my area here is 80%. I already know that. My mean here is my 36.9, and I'm trying to find this critical value. Okay, what number is the delineation between 80% and then the highest 20%? And that's what this number means. I hope by drawing these pictures, it helps to make it more clear in my mind, and hopefully it will in yours too, so that 80% of smartphone users are in that lower range, okay? They're from 48.6 or less. We'll just go through some of these examples at the end of this PowerPoint, just to make sure you understand how the calculator is going to be helping us to solve these. Here we have a disease, and the Ebola virus is normally distributed, the incubation period. Mean of 12 days, that's in our middle, a standard deviation of 4.5 days. Find the probability that a randomly selected case demonstrated symptoms in fewer than 7 days. So thinking about this, 7 is a lot less than 12. So we're talking about that tail end of our problem. So looking at, it's actually has a little bit of multiple choice here. Which of these would be appropriate for that? Now I'm going to draw a picture, which I'm sure you either will or will not appreciate, but that's okay. This is my mean, which is 12, right? And we're talking about 7. A selected case demonstrates symptoms in fewer than 7 days. So we're interested in this area. Which of these is going to get me that area? Well, I'm going from negative large number up to 7. The one that says that is right here at A. Negative large number up to 7 with my mean and my standard deviation. Okay. The other ones do not show that. This one would be an upper limit. This one would show all of this area. And these are just kind of confused, right? This would be the whole thing minus my CDF from the mean upward. It is A, definitely A. And inverse, no, because I am trying to find the probability. I am not given the probability. Hopefully those hints help a little bit. Girl Scout cookies. Find the probability that one randomly selected cookie has a size more than 0.27 ounces, and if the standard deviation is 0.03 ounces. Assume a normal distribution. So here, I'm given the information, and let's look at what our options are. I'm going to draw a picture. Maybe it won't let me. Okay, my mean is 0.25, and I'm looking at 0.27, which is this side of the mean, and I'm looking at more than, so I'm looking at this portion here. Okay, which one of these would demonstrate this? This one would demonstrate starting at negative and going forward. That's not what I'm after. This one starts at 0.27 and goes forward a very large number. If the standard deviation is right and the mean, then that is the correct one. So at this time it would be B. Anatomy. Again, we are given a mean and a standard deviation. And the question is, if the incoming ray of light has wavelengths between, and it gives me a little bit of a parameter here, calculate the percentage. So I'm going to have 2 limits on this. I'm going to have a lower limit and an upper limit. And right away, hopefully, you can see that I'm going to have right in here, my lower limit and my upper limit. Well, no.